Hey guys, welcome back. It's time for lesson 13.3, the unit circle. In order to understand what we're talking about with the unit circle, the first thing we have to talk about is what we call radian measure. So far, we've only measured angles in degrees, but you can also measure them in radians. And you may remember radians from geometry. I'm not sure how much you talked about it when you talked about circles. But a radian, if you see here from the textbook, is a unit of angle measure based on arc length. In geometry, an arc is an unbroken part of a circle. If the central angle theta in a circle has a radius of r and it intercepts an arc of length r, then the measure of theta is defined as 1 radian. The important part to see here is this part here. The circumference of a circle with a radius of r is 2 pi r. Therefore, an angle representing one complete clockwise rotation is 2 pi radians. You can use that fact that 2 pi radians is equivalent to 360 degrees to convert between radians and degrees. And actually what we're going to use to convert is half a rotation, because if a full rotation of a circle is 360 degrees, that's 2 pi, so half a turn would be 1 radian, or pi radians I should say, and it would be 180 degrees. So if we look at the notes, as I said here, radians are real number measures of rotation. To convert between radians and degrees, we use the following. You have to understand that pi radians is the same as 360 degrees. So to convert from degrees to radians, I use this. You're going to multiply by the ratio pi over 180. If you want to convert from radians to degrees, you're going to multiply by the reciprocal, 180 over pi. How does that work? Well, let's take a look down here. If I want to convert 360, not 360, I'm sorry, just plain old 60 degrees to radians, I'm going to multiply that by pi over 180. The degree parts are going to divide or reduce, and I get pi over 3. So 60 degrees is pi over 3. To convert 5 pi over 4 to degrees, I'm going to multiply that by 180 over pi. The radians are going to cancel, the pi's are going to cancel. 5/4 times 180 becomes 225. So 5 pi over 4 is 225 degrees. Now this works if you have positive angles or if you have negative angles. If we look at number 1 here, negative 45 degrees converted to radians, we're going to multiply by pi over 180. So basically that is going to end up reducing, and I need my calculator, and it's going to be, let's see, 45 divided by 180 is 0.25, or 1/4. So what we get here is really 1 pi over 4. I mean, let's do this. It should be technically negative 45 pi over 180. So that becomes negative 1 pi over 4, or negative pi over 4. To convert 150, well, this is going to reduce. Let's see, 150 over 180, that becomes, let's see, 150 divided by 180 is 0.83. Repeating, change that into a fraction, it's 5/6. So we end up with 5 pi over 6. 210, we're just going to do this. 210 degrees times pi over 180. You really don't have to write out radians because it's kind of assumed that that's going to be the case. All right, so 210, that's going to be more than 1. 210 divided by 180 is 1.16. Repeating, convert that to a fraction, it is 7/6. So this would be 7 pi over 6. And then this, again, negative 120 times pi over 180. That is negative 2/3, so that's going to be negative 2 pi over 3. Just a minute. Okay, let's keep going. Converting radians to degrees. Well, like I said, you're going to set it up, and instead of pi over 180, it's going to be 180 over pi. So what's going to happen here is the pi's are going to cancel out. 3 and 180, that becomes 60. So 4 times 60, this is going to be 240 degrees. Negative pi over 2 again. The pi's cancel. 2 and 180, that's going to become 90. Oh, there's the bell. Lunchtime. So negative 3 times 90 is negative 270 degrees. Pi over 6, easy. Pi over 6 times 180 over pi. And again, you really don't need to write out radians. Don't worry about it, because I see a pi, I know it's radians. The pi's are going to cancel. 6 divided by, or 180 divided by 6 is 30 degrees. 5 pi over 3. Going to multiply that by 180 over pi. The pi's are going to cancel again. 3 goes into 180 60 times. 5 times 6, this is 300 degrees. All right, so what does this have to do with the unit circle? Well, let me show you. Here it is. The unit circle is a circle with a radius of 1 unit, and every point xy on the unit circle has an r value of 1. If you recall in yesterday's homework assignment when you were finding trig values for a given point, well, this time we're assuming that r is going to be 1, and then we've got xy all the way around here. So basically what happens is this. For an angle theta in standard position, the sine of theta is just y, the cosine of theta is just x, and then the tangent is still going to be that y over x. What this ends up creating is this situation here where these coordinates, these dots around here, these points, end up being, instead of xy, they can be considered cosine theta, sine theta. And so this diagram here shows you all the major angles. This is going to be important because you're going to have to, at some point very soon, create your own unit circle, and you're going to have to get all artsy and or fartsy about it, and well, you'll see. So how does this work? Well, let's go back to the note page and let's figure this out. You can use reference angles to find the exact sine, cosine, and tangent of any angle in any quadrant. So how do we find the trig functions for, say, 150 degrees? Well, the reference angle for 150 is 30. So because 180 minus 150 is 30. So the sine of that is just going to be 1/2. Cosine, square root of 3 over 2. Tangent, 1 over the square root of 3, which, remember, is really the square root of 3 over 3, because we don't want those radicals in our denominators. And that's going to work basically all the way around the circle. So to adjust the signs for 150, well, in this first quadrant, we're positive, positive. In the second quadrant, we are negative, positive. In the third quadrant, we are negative, negative. And in the fourth quadrant, we are positive, negative, right? We know that. Well, if we consider this to be cosine theta, sine theta, instead of xy, so what ends up happening is, in the first quadrant, both these values are positive. In the second quadrant, cosine's negative, but sine is positive. In the third quadrant, cosine and sine are negative, but tangent is positive. And then in the fourth quadrant, cosine's positive, but sine's negative. And of course, tangent will also be negative. So, sine of 150 is going to be the same as the sine of 30. It's going to be 1/2, because of the reference angle. cosine is going to be negative, so it'll be negative square root of 3 over 2, and then the tangent of 150 is going to be negative 1 over the square root of 3, which, remember again, is negative square root of 3 over 3. So how would we do this, like to find the exact values for 315 degrees? Well, the reference angle, it's right here in the diagram. The reference angle is going to be 45 degrees. So the sine, cosine, and tangent of those, well, sine of theta is 1 over the square root of 2. Cosine of theta is the same, 1 over the square root of 2. And then tangent is 1 over 1. Now these are going to become the square root of 2 over 2. And of course tangent's just 1. So now if we have to adjust for an angle of 315, we're in this fourth quadrant, and if you recall, let me move the notes back up just so you can reference this. Cosine's positive, but the other two values are going to be negative. So I would say the sine of 315 is going to be negative square root of 2 over 2. Cosine of 315 is positive square root of 2 over 2. And tangent of 315 is negative 1. And these theta here, theta is 45 degrees. I probably should have wrote that out, but anyway, that's that. So that is kind of mostly what you're going to be doing. If you look at example number 2 in your textbook, how do I find cosine of 210? I can just find 210 on this. It's right there. Cosine is going to be negative square root of 3 over 2. Sine would be negative 1/2. Once you've got a unit circle created, you can find any of these really easily. The nice thing about this unit circle too is it's already converted all the degrees to radians as well. So if I want to find the tangent of 5 pi over 3, well, 5 pi over 3 is 300 degrees. So tangent is going to be y over x. So that would be negative square root of 3 over 2 over 1/2. Work it out, that's negative square root of 3. And that's it. So to find reference, you find the reference angle. As I said, you use quadrant 1 to find cosine and tangent, and then just adjust. And here's another little bit here that kind of does the same thing I just showed you in the note sheet. That's a nice color one there. 225, find the reference angle, it's 45. However, when you're in that third quadrant, everything's negative, but tangent, so tangent would be positive. It's just that kind of, it's really simple. So really what you really need to know is all the first quadrant angles, and then you can adjust for positives and negatives as you go around the unit circle. So the most important ones are these guys here in the first quadrant. And I just want to make sure there's nothing else before I wrap this up. If you know the measure of a central angle of a circle, you can determine the length S of the arc of the intercepted angle, and basically they derive that formula. The length of the arc, if you know what theta is and you know what the radius is, it's radius times theta. That's it. That's the arc length formula. So here, why do we care? Well, there's a lot of engineering applications for this. And it's lunchtime again. A human centrifuge device is used to train astronauts. There's an astronaut riding inside that little car, and he's going around and around and around to simulate zero gravity. Find the radius of the centrifuge. If the centrifuge is 58 feet across, the radius is 29 feet. Find the angle through which the cab rotates in 1 second. So we're going around the central hub. So let's see, it makes 32 revolutions in a minute. So how many would that be per second? Well, theta radians in 1 second would be 32 times 2 pi radians in 60 seconds. That would be 16 pi over 15. Multiply that by 29, which is the radius, and you get an arc length of 97. So it goes about 97 feet per second. You may or may not have some homework problems that use this arc length formula. Just keep that in mind. So that's it. That's your assignment. I hope you learned something today. If you do, make sure you smash that like button as always. And I will see you in the next one.